Hello all. In today's session, let we learn about random access memory. So where RAM is one of the memory device. So it comes under your classification of your memories. So one of the memory devices is RAM. So we were going to learn about. So what will be the RAM structure, how the process of write is done in your RAM as well as your read operations. So from your how you are obtaining your output from your RAM, those are the things we are going to learn in this today's session. Now, so let me learn about your random access memory with this block diagram. So where this block diagram consists total number of words are 2 power k, and in each memory location you can have your n bit. So for each word that consists of n bit. So hence we require n number of data input lines and n number of data output lines. Basically, these RAMs also are defined as a memory device, which is a collection of memory cells, where in each memory cell you can hold your 1 bit of data. So now these data can be defined with the 1 bit, 1 byte, or with the words. So 1 byte is nothing but your group of bits. So for a collection of 4 bits is called nibble. In the same manner, a group of 8 bits is called as 1 byte, and 2 bytes is known as your 1 word. So now you have to communicate your memory with your outside environment. So we require some data input lines as well as your output lines. So using those data input lines and output lines, we can retrieve your data from that data output lines, and you can enter the data through your n number of data input lines. Next, in order to select one of the memory words, so we have to use your number of locations. Based on your number of locations, you can have your address selection lines. So here it is defined with 2 power k number of words. So hence it requires k number of address lines. And it also additionally would have here 2 control lines, where based on this enabling of your read or write control inputs, you can perform one of the memory read operation or one of the memory write operation. So now memory read operation can enable your location, and the data will be retrieved through the end data output lines. That is called as memory. Retrieving a data from its selected memory location is known as your memory read. So entering your new data through control inputs of your write upon enabling your write signal and selecting your a particular memory address through this k number of address lines. So by passing your a new data through this n data input lines, you can load the data into your selected memory location is known as your memory read operation. Now the size of the memory is denoted with kilos or mega or with a giga or with your terabytes. So if a kilo is 2 power 10 number of locations, mega is 2 power 20, giga is 2 power 30. For example, now your memory is 64 kilo. 64 kilo means, so it requires total number of address lines are 16 number of address lines. Since here that 16 is indicated, 64 is indicated as 64 is 2 power 6 and kilo is 2 power 10. So 2 power 6, here 2 power 6 into 2 power 10, so which is equal to 2 power 16. The same manner 2 mega means 2 into 2 power 20, so which is equal to 2 power 1 is 2, so 2 power 21. So we require total number of address lines in order to locate here one of the memory location of 2 mega words. So next, in the same manner, 64 kilo requires 16 number of address lines. Next, 4 giga is 2 square is 4, giga is 30, hence it requires total 32 number of address lines to locate your one of the memory address. So here, so if it is k means, so the number of memory words available are started with 0 to 2 power k minus 1. In the same manner, if it is having that number of 2 power 16 2 power 10, always it is equal to 1024 number of memory locations are available. So now here if it is given with the 2 power 4, so 64 kilo means, so it requires total number of lines are 2 power 16. So it will start with 0 to the last memory location is 2 power 16 minus of 1. So now next 2 mega means, so here 2 power 21, so hence it will start with 0 to 0 is the first memory location and the end location must be equal to 2 power 21 minus 1. So like this, so we can have here the number of memory locations which are identified using here the address bits. The same manner, so you can also have a write operation in order to obtain the write operation. So we need to first select the memory. So using this address register, so we can transfer the address bits, so that address bits are transferred through this address bus. So bus is used for transporting the people in the same manner. Here it will transfer the content of your address register to the address decoder input. So hence we are calling this as a address bus. So if it is having total number of locations are 8, then it requires the number of address bits are 3. So hence the order of the decoder is equal to 3 is to 8 or 3 by 8. So the first number denotes the number of address bits required and the second number denotes the number of memory words or your memory location which are available in this memory, in this random access memory. Address register, if it is 101, so the fifth one is selected, the fifth memory location is selected. Now based on your control operation, so if it is a write, so you have to enable your write input, activate your write input, and now the data must be loaded onto the data register which you wanted to store into the selected memory location. So now using this data bus, so you can transfer the data register content upon enabling the write signal and selecting your particular memory location. So that data content from the data register is traveled towards to the data bus and will be loaded to the selected memory location is called as a memory write operation. So storing the new data information into the selected memory is called as your memory write operation. And now here the data bus is traveling from your data register into the memory, so which is a bidirectional device, bidirectional bus. So this shows the bidirectional data transfer. So you can transfer the data from your memory to the data register, or you can transfer your data register content which is loaded into the memory. Hence data bus is a bidirectional one, whereas address bus only have one way of entering your data. So you can only transfer the data of your the address register content to the input of your decoder, address decoder. Hence only it is known to be the unidirectional. So address bus is a unidirectional one, whereas data bus is a bidirectional one. So since you can take out the data from your memory and that can be loaded into the data register, hence your data bus is bidirectional, whereas address bus is a unidirectional. Next, so in read operation, so when you wanted to transfer new information into the memory, first we have to select the address of your memory location, sorry, your one of the memory location using the address. So first load your address register content and transfer that through your address bus. So and that address bus is applied as your input to the address decoder. So these are 3 bits data 011 will select your third location. When we selected the third location, so by enabling your control input read signal, the data of 8-bit data here I have, so which will be traveled through your data bus and loaded into the data register. So from this data register you can process the data or you can transfer through the to the output devices. So this is about our read operation which can be performed in a random access memory. Now coming to the types of RAM, so based on your how this memory or the information is holded into the memory of your RAM, so it is classified into dynamic RAM and static RAM. So all static RAMs are categorized using your or they are constructed using your flip-flops. So which where your memory cells are constructed using your flip-flops. So like you can have your set of field effect transistors where those all are operated with your supply voltages of 5 volts. So now always these static memory cells would require the power. So now, so in order to store the data permanently into that RAM, so we always have to apply that supply voltage. If the power is removed, the state data bit also lost. So now these cells selected by enabling your address inputs or the select inputs. So now once it is selected, you can enter the data bit of 1 or you can load a data bit of 0 permanently onto that cells. So now once the power is lost, so power when it is removed, so the data will also be lost in your static RAM. So here, so it will be each memory cell is designed using your flip-flops. So flip-flops can consist your total number of FETs must be or 5 number of FETs we can use. So here the binary cell is constructed using these flip-flops can make that size of the static RAM to with a very less space devices. So and bulkier one. So because of the flip-flops usage in your static RAM. Whereas in dynamic RAM, so these dynamic RAMs are constructed using a simple capacitor with a refreshing circuitry, and based on the charging which is acquired on your capacitor, you can hold your data of logical one, or when the capacitor is discharged, so then it can be we can read out that data is a logical 0. So in order to select this binary cell, so each binary cell consists only one capacitor. So always these capacitors are all of passive components, and there is a tendency of your losing the information. So because so your capacitor naturally the charge on your capacitor is discharging, so hence we require a refreshing circuitry in order to keep that charge onto the capacitor. Always must be it require a refreshing circuitry. So for every a certain time interval it has to be recharged. So hence it require a refreshing refreshing network. So both SRAM and dynamic RAMs will lose the stored data when the power is removed from their cells. So now hence these comes under your volatile memory. So data can be read much faster than your from your SRAM than from your DRAM. So since in your DRAM you are going to use your passive elements of capacitor, whereas SRAMs are used with the active elements of a field effect transistor or the flip-flop. So hence compared to your DRAM, so your SRAMs are faster, and these SRAMs are used for a short storage as a cache memory. So now however DRAMs can store much more data because so these only consist only the capacitor with a refreshing circuitry. So hence so in order to store a larger data, so you can prefer your dynamic RAMs, or for a small data of information or for a smaller size of your memory, so you can prefer your static RAM. So now, so this is about our classification of your random access memory, and as well as how the read and write operation is performed on your random access memory. Next session we are going to start here